In this problem, what we're going to be looking at is we're going to be looking at concentrations and some unit conversions as well too. So the problem reads as such. Fluoride ion, poisonous in relatively low amounts, so toxic level is going to be 0.2 grams of fluoride per 70 kilograms of body weight can cause death. So if a 70 kilogram individual, which would be somewhere around 250, 260, 150, 160 pounds, if they take 0.2 grams of fluoride, that can cause death. Nevertheless, in order to prevent tooth decay, fluoride ions are added to drinking water at a concentration of 1 milligram of fluoride per liter of water. Now, the toxic level, the toxicity, is going to be 0.2 grams, or that's equal to 200 milligrams, all right? And the concentration of the fluoride is going to be 1 milligram per 1 liter of water. Now, the first question asks, how many liters of fluorinated drinking water would a 70 kilogram person have to consume in one day to reach the toxic level? So how many gallons of water, if your city's municipality puts in 1 milligram per liter of water, how many liters of water would you have to consume in order to get to the toxic level of fluoride to injure or harm it or kill an individual? B says, how many kilograms of sodium fluoride would be needed to treat 8.50 times 10 to the 7th grams reservoir? Okay, reservoir. All right. Now, for A wants to know how many gallons or how many liters of water would an individual have to drink. Now, if we take the 200 milligrams of fluoride and we divide that by the 1 milligram of fluoride per liter of H2O, the milligrams of fluoride are going to cancel out. We have an inverse of an inverse, and this gives us 200 liters of water. Now, to give you an idea of the volume of that, 200 liters, we don't typically deal in liters here in the United States. To give you an idea about that, divide it by about 4. There's approximately 4 liters per gallon. If you divide this by 4, you come up with about 50 gallons of water. So if an individual drank about 50 gallons of water in one day, they would have enough fluoride in their system to potentially cause death. Now, the death, if you drink 50 gallons of water, is not going to be from the fluoride. It's going to be from the dilution of the ions in your body, and thus not allowing the electrical impulses within the body to work properly. And so essentially, the individual would succumb to too low a concentration of ions and would thus probably perish. Part B of this problem, we want to know how much sodium fluoride will go into, do we need to add to 8.5 times 10 to the 7th gallons of water. So this obviously is going to be a city municipality, their public water works. We need to add some sodium fluoride to this amount of water such that the concentration of the fluoride will be 1 milligram per liter. We got a lot of things going on here. We got this gallon. We got to convert that into liters or convert the liters into gallons. I've chosen to convert the gallons into liters, and there's 3.785 liters in 1 gallon. So approximately 4 liters per gallon. The gallons cancel, and it gets us to 3.217, make that point up here, times 10 to the 8th liters. That's the amount of water we have in liters. Now we want to find out how much fluoride do we need. Well, if we take 3.217 0.217 times 10 to the 8th liters, and we multiply that by our concentration. So that's 1 milligram of fluoride divided by 1 liter of water. Once again, that's going to be units of water, liters of water, so that cancels. And what we get is we obviously get 3.217 times 10 to the 8th milligrams of fluoride. Now that's fine, that's okay. We could convert this into kilograms, and this gets us to 321.7 kilograms of fluoride. But the question asks, we want to know the amount of sodium fluoride. Now sodium fluoride is NaF, and if we want to find out the mass percent of fluoride in sodium, because we can use that mass percent of fluoride in sodium fluoride, use that for our amount of the mass of fluoride we have, and determine how much sodium fluoride we're going to add. We don't just add fluoride, we have to add a cation with that anion. So we can find then the mass percent of fluoride in sodium fluoride. To do that, we're going to use the molar mass. The molar mass of fluoride is 19 atomic mass units. The mass of sodium fluoride, the atomic mass of sodium fluoride, is 42 atomic mass units. We multiply that by 100, and we get 45.2%. If we take the 45.2%, convert that back into a decimal form, so that gives us 0.452 is equal to the mass of fluoride, which is 321.7 kilograms of fluoride, divided by X kilograms of sodium fluoride. This number right here will tell us how much sodium fluoride we need to add to the 8.7 times 10 to the 7th gallons of water. We do the simple arithmetic, and X is equal to 701.13 kilograms of sodium fluoride. So if you add 711.13 kilograms of sodium fluoride into this amount of water, you're in essence putting in 321.7 kilograms of fluoride, which will give a concentration of 1 milligram per liter. And so this is the amount of sodium fluoride that will be added to 8.7 times 10 to the 7th gallons of water. If you have any questions on this problem or any other ones, please let me know.